Greetings everyone, you are welcome in this tutorial. In this tutorial, we will talk about sorting and merging arrays using C++. So what is sorting? Sorting refers to the task of arranging the elements of an array in either ascending or descending order. Now let us see what is ascending and descending order. If A is an array with n elements, then in ascending order, A0 is less than A1, which is less than A2, and so on till An. It means the first element is the smallest element, the second element is the second smallest element, and so on. That is, all the arranged elements are arranged in increasing order. In descending order, A0 is greater than A1, which is greater than A2, and so on. That is, the first element is the biggest element of the array, which is followed by the next element, which is the next biggest element, and so on. That is, all the elements of an array are arranged in decreasing order. There are many types of sorting operations. In this video tutorial, we will discuss about selection sort, bubble sort, and insertion sort. Now in selection sort method, to sort an array in ascending order, the smallest element is searched from the array and it is swapped with the first element. Then the second smallest element is searched and it is swapped with the second element with the element in the second position. And this process continues for all elements of the array. Now to sort an array in descending order, instead of smallest element, the largest element is searched and it is swapped with the first element of the array, and the process continues for all elements of the array. Now let us see a program in C++ to sort an array using selection sort. Now this is a program. Here, this is the header file. Now we are writing a function. This is a function prototype to sort an array. Now this is a constant integer size of an array for an array is declared of size 6, and then we are declaring an array of size 6 and we are initializing it by some values, and you can see that this array is not sorted. All the values are in random order. Now we are calling the function selection sort, in which we are passing the array and the size of the array to sort this array. Now let us jump to this function. Now in this function selection sort, you can see here we have again an array A, which is nothing but the array R only, and an integer n, which is the size of the array. Here we are declaring three variables, small, pause, and temp, to hold the calculation values. Now there are two loops to perform this operation. In the first loop, we will go to each and every element of the array, and the second loop is used to search the smallest element from the rest of the array. Now in the first loop, we will first store the position of the first element of the array in the variable small and its position in the variable pause. Now we will run the next loop from I plus 1 till n, and we will search the smallest element. And if an element is found which is less than small, we will simply store the value of this element in the variable small and its position in the variable pause. Now at the end of this loop, the variable small contains the smallest element of the array and pause will contain the position where this element is stored. Now the next step is to swap the position of this element with the first element of the array. So to swap, we will declare a variable temp and store in it the value of the first element. Now in the first element, we will store the element which is the smallest element of the array, which is stored at position pause, and then the position at which the smallest element was found, at that position the first element of the array is stored. So we display the contents of the array after this pass. So this loop will be used to display the contents of the array. So at the end of this loop, the first loop, all the elements of the array will be sorted, and when this function will over, the sorted array will be returned back, and when we will display this array using the for loop, we will get the sorted array. Now let us understand it more deeply using a memory diagram. understanding of passes is very important. What happens in each pass? So let us discuss first pass first. So in the first pass, you can see I is 0, small is 56 and pause is 0. You can see here, this is my original array and I is 0, small contains AI which is A0 and pause is equal to I which is again 0. Now this is the loop for searching an element, searching the smallest element from the array. Let us see how this loop actually functions. Now in the beginning, j is equal to I plus 1. So I is 0, so j will become 1. Now the condition is true because 1 is less than 6, n is 6 here. Now if aj less than small, now we are checking this condition. What is aj? Aj you can see is 48, a1 is 48 which is less than 56. The condition is false. So we'll simply go to update expression which is j plus plus. We'll increment j. Again we will check 2 is less than 6. The condition is true. So we will again go to this if condition. Aj less than small. So aj now is 75. You can see here the second element is 75. 75 less than 56. Again this is false. So j is incremented. Now j will become 3. 3 is less than 6. The condition is true. Now again we will check what is a3. A3 is 19. So 19 is less than 56. So this condition is true now, you can see. Now when the condition is true, we will store the value of this element in the variable small. Now small will become 19. You can see from next onwards we will refer to small by the value 19 and pause will contain 3. Now again the j will be incremented. J will become 4. Now 4 is less than 6. The condition is true. And at the fourth position, you can see at the fifth position, or you can say 26 is present. So 26 is less than 19. So this is false. So again this condition is false, so nothing will happen and j will simply be incremented. J will be incremented and it will become 5. 5 is again less than 6. The condition is true. So again we will come to this if statement. Aj less than small. What is aj here? Aj is 15. So 15 is less than 19. The condition is true. So as soon as the condition will become true, we will store the value of this element in the variable small. So you can see small is 15 now and pause is 5. Now j is again incremented. J will become 6, but 6 is less than 6. So the loop will be terminated because the condition is false. So the inner loop will be terminated. Now after the termination of the loop, the next step is that we will swap the element which is present at this. Now we see that the smallest element is present here. And now the next step is to swap the position of this element and the position of the very first element. So we can see here now the 15 is copied here and 56 is copied here. So after pass 1 my array will look like this. So you can see that we are not discussing all the passes in detail, but in every pass the same procedure will happen. And after every pass, you can see first pass the elements are swapped like this. In the second pass, you can see the 19 is the next smallest element. This will be swapped with the second element. So here the 19 will come and here 48 will come. And in the third pass, you can see this is the array. 26 is the next smallest element. So 26 and 75 will be swapped. So you can see 26 will come here and 75 will come here. And again in the next pass 4, you can see 48 is the next element and this is the smallest element itself. So there will be no swapping and 48 will remain at this place only. And in the fifth pass, you can see this is 75 and this is 56. So they will be swapped because 56 is smaller than 75. So 56 will come here and 75 will come here. So you can see at the end my entire array is sorted. This is the method of selection sort. Now let us come to bubble sort. Now in this sorting technique, the adjacent elements of the array are compared and interchanged if required. Instead of selecting the smallest element as in the selection sort, here adjacent elements are compared. Multiple swapping takes place in one pass and smaller elements move or bubble up to the top of the array and hence the name given to this technique. That is why this technique is called bubble sort. At the end of the first pass, you can see here, the largest element of the array is bubbled up to the end of the array. And this is for sorting the elements in ascending order. And in descending order, the reverse will happen. The smallest element will bubble up to the end of the array. And this process continues for all the n-1 elements. And in this technique, we can take the advantage to quit early. That is, the number of passes can be less than n minus 1 for an array of n elements. It can be less. Otherwise, the number of passes is always n minus 1 in all the other sorting techniques. Now let us see a program in C++ to perform bubble sort on an array. So this is the program. This is the header file we have included, and this is the bubble sort function. So again, let us start from main. This is the main in which we are declaring a constant integer of size 6, and then we are declaring an array of size 6 in which we are storing some values. You can see here it is, these values are not in sorted order. Now we are calling the function bubble sort in which we are passing an array and its size. So let us call this function. So you can see here this is an array A which points to array R, and n is the formal parameter which takes the size of the array. Again we are declaring a variable temp, temporary variable. Now in this again two loops are required. The first loop runs from 0 till n minus 1, and the second loop runs from 0 to n minus 1, less than n minus 1. So you can see here in this we are comparing aj greater than aj plus 1. We are comparing the adjacent elements. And if aj we find aj greater than aj plus 1, we are simply swapping their values. We are storing aj in temp, and then we are storing aj plus 1 in aj, and then we are storing temp in aj plus 1. So after the completion of these loops, at the end of this loop, the largest element bubbled up to the last position, and this loop is going to this loop is for number of passes, and at the end of both the loops our array will be sorted, and it is returned here. And if we use this loop to display the elements of the array, you will find the entire array is sorted. So let us again understand it through a memory diagram to make it more clear. So this is the memory diagram. We can understand the passes. Again, I am saying passes are very important. So in the first pass, you see I is 0 and n is 6. This is my array before the first pass. And let us see what will happen in this loop. Now in this loop, we are saying j is equal to 0, j less than n minus 1, j plus plus. We are starting from the 0th element itself. So j is 0, and this condition is true because 0 is less than n minus 1. Now we are saying if aj greater than aj plus 1. So j is 0. So aj greater than aj plus 1 is a0 greater than a1. We can see a0 is 56 and a1 is 48. The condition is true. So in this case, the swapping will take place. a0 will contain the value 48 and a1 will contain the value 56. You can see here the swapping has taken place. Now 48 is here and 56 is here. Now j will be incremented and j will become 1. Again the condition is true because 1 is less than 5. Now if again we will check whether aj is greater than aj plus 1. So now a1 is greater than a2. You can see a1 is 56 now. We have this array now. a1 is 56 and a2 is 75. So we'll check, is 56 greater than 75? No, the condition is false. So no swapping will take place and j will simply be incremented and by 1. So j is now 2. Again the test condition is true, and again we will check. Now we will check a2 greater than a3. So you can see a2 is 75 and a3 is 19. Yes, the condition is true. 75 is greater than 19. The swapping will take place. a2 will take the value 19 and a3 will take the value 75. So you can see here the change has been taken place. a2 is containing 19 and a3 is containing 75. So again j will be incremented, j will become 3, 3 is less than 5. Again we will compare a3 greater than a4. So you can see a3 is 75 and a4 is 26. So the condition is true. So again the change will take place. a3 will contain 26 and a4 will contain 75. You can see the swapping has been taken place. Again j will be incremented. Now j will become 4. 4 is again less than 5. The condition is true. So we will compare a4 greater than a5. So a4 is 75 and a5 is 15. It is true. So the values are swapped. a4 will now contain 15 and a5 will contain 75. You can see that at the end, and now again let's see the next one. After the incrementation of j will become 5, and you can see 5 is not less than 5. So loop termination will take place, and After the terminated loop, this is the array after pass 1, and you can see at the end of pass 1, the biggest element of this array is 75, and it has bubbled up to the end of the array. So in the second pass, the second biggest element will come here. In the third pass, third biggest element will come here, and so on. So this is how bubble sort actually works. So after all the passes, you can say after the pass 1, we have 75 changed here. And after the pass 2, 56 is the biggest change, the next biggest element. After pass 3, the biggest change is the 48, which is bubbled up to the third position. After pass 4, 26 is bubbled up to this position. And after pass 5, 19 will come here, and then 5 will automatically come to the first place. So this, you can see the entire array is sorted at the end using bubble sort. Now let us talk about insertion sort. In this sorting technique, the array is divided into two parts, sorted and unsorted. Now to sort an array of n elements, we first assume that element at 0th position is sorted, and the rest of the elements they form the unsorted portion of the array. In every pass, an element is compared with all elements before it, and suitable position is found for the element in question, and space is created for it by shifting all the other elements one position to the right. So we take an element from the unsorted portion and we try to shift it to the sorted portion in a sorted manner. So to place it in a sorted manner, we sometimes have to make some shifting and we have to make a space for that element, and then that element is inserted at the right position. And this procedure is repeated for all the elements in the array. Let us take an example. First, let us write down a program in C++ to perform insertion sort. So you can see here, this is the program for insertion sort. This is a function in which there are two elements. We will start from main first. This is the insertion sort function. So void main. Again, we have declared size as 6, and we are declaring an array of size 6, and these are the numbers by which it has been initialized, and they are in sorted order. They are in random order. And now we are calling the function insertion sort to sort this array, and we are sending array and its size as a parameter. Now we'll come to insertion sort function. Again, a and n. A refers to array and n contains the size of the array. We are declaring three variables I, j and temp. Now again, to perform insertion sort, two loops are required. One loop in this loop, instead of starting from 0, we have started from 1. This is very important because we have already assumed that element which is present at the 0th position is the sorted portion of the array. Now we will scan our array from the element number 1 till n minus 1. So we will store the position of this element in a temporary variable, and j is equal to I minus 1. Now we are making a space to insert this new element. So we are checking whether temp is less than aj or not, and j should also be greater than equal to 0. If it is, we will move aj plus 1 is equal to aj. We are moving the elements one step back, and after the completion of this loop, the space has been made for the new element, and then we are inserting this element using this statement. Aj plus 1 is equal to temp. So temp will be inserted at the j plus 1th position. So this is how all the elements are displayed after each pass. And at the end of this function, the entire array will be sorted. And when we come to the main, this can be displayed using this loop. Now let us see the memory diagram of it to make it more clear. Now this is my original array. Now in the first pass, I is 1 and temp is. So we are assuming that 56 is already sorted. It is at the sorted position of the array, and temp is 48, the first element, and j is 0. Now j is 0. You can see here. This is we have come here. Temp is equal to ai. We have already written j is equal to 0. Now while temp less than aj. Now we are checking this condition. Is temp less than aj and j greater than equal to 0? So what is temp? Temp is 48 and j is 0. You can see here. So j is 56. So 48 is less than 56 and j is 0. So 0 equal to 0. So this conditions, both the conditions are true. So swapping will take place as both the conditions are true. aj plus 1 is equal to aj. J is 0. So a1 is equal to a0. So in the first position, 56 will come. A1 will contain the value 56. Very important to understand. Now j will be decremented by 1. See, we are decrementing j, and j will become minus 1. J should be greater than 0 to continue this loop. So the loop will terminate, and then we are saying aj plus 1 is equal to temp. J is minus 1, so minus 1 plus 1 is 0. So a0 will become temp, which is 48. You can see a0 is containing 48 and a1 is containing 56. Now this is the sorted portion of my array, and this is the unsorted portion of the array. Now let us do some more passes. In the pass 2, we have temp as 75. You can see here temp is 75 and j is 1. Because I is 2, that is why temp is 75. This is my array. Now j is 1. Now we'll check this condition. Temp less than aj. 75 is less than 56. You can see here. And 1 greater than equals to 0. So 75 is not less than 56. The condition is false. So this loop will terminate, and the update, and we will simply write aj plus 1 is equal to temp. We can see a2 is equal to 75. So we have simply written. Now this is the sorted portion of the array, and this is the unsorted portion of the array now. Now let us understand other passes also. In the third pass, I is 3 and temp is 19. Now this is the element which we have to insert in the sorted portion of the array. Now I is 3, so j is 2, because j is always n minus 1. So j is 2. Now let us check this condition. This condition we have to check. Temp less than aj and j greater than equal to 0. Temp is 19. 19 is less than 75. Yes. And 2 is also greater than 0. Both the conditions are true. So a3 is equal to 75. You can see aj plus 1 is equal to aj. J is 2. So a3 is equal to aj, which is 75. So 75 will come here. And then j will be decremented. J will become 1. Now again we will check the next element. Next element, 19 is less than 56. You can check this element. Temp less than aj. So 19 is less than 56 and 1 is greater than 0. So this condition is true again. So if the condition is true, we are copying aj to aj plus 1. So a2 will now contain 56. Again we will decrement j. J will become 0. So now again we will check this condition. If temp less than aj, temp is 19. So aj is a0, which is 48. So yes, it is greater than it is less than temp. Temp is less than aj, and j is also equal to 0. J is 0 is equal to 0. So conditions are true. So aj plus 1, j is 0, so a1 will become 48. You can see here. And if we further decrement j, j will become minus 1. So this condition will become false and the loop will terminate. And after the termination of this loop, we will come to this statement, and a0 will contain the value 19. So this is, you can see how we are making space for this element 19. We are shifting all the elements one step back so that we can make space for 19. So similarly, these passes will also take place in the pass 4. I will have value 4 and temp will have value 60 and j is equal to 3. This is 60. So we will check here. The control variable j is equal to 3. 60 is less than 75 and 3 is also greater than 0. The condition is true. So we will shift 75 to this position. But if we will then j is incremented and j will become 2. Now we will again check 60 is not less than 56. The condition is false. This condition will become false. We'll come to this statement, and a3 is equal to 60. So you can see a3 is 60 and a4 is 75. And similarly, after the first pass, see we have to insert 35. It means we have to shift all these elements, all these 4 elements one step back so that we can make space here. So this is what we have done. J is equal to 4. So you can see these conditions are true. So a5 will become 75. 75 will come here. And similarly, the next condition is also true. So a4 will become 60. Next condition is also true. So a3 is equal to 56. See, all the elements we are shifting backwards. And j is 1. Again, this condition is true. So a2 is equal to 48. But next time, the condition is not false. See, 35 is not less than 90. So the loop will terminate. And aj plus 1 is equal to temp. So a1 will contain value 35. So you can see after the 5th pass, all the elements are in the sorted order. So if we see all the passes together in this array, we can see after the first pass, these 2 elements are sorted. After the second pass, these 3 elements are sorted. After the third pass, these 4 elements are sorted, and 5 elements are sorted, and then all the 6 elements are sorted after the pass 5. So n minus 1 passes are required to sort an array of n elements. Now let us come to merging. Merging is a process of combining the elements of two sorted arrays into a third array in a sorted manner. It means there are two arrays are given to us which are in a sorted order. It can be either ascending or descending, and we have to merge the content of both the arrays in a third array in again a sorted manner. So to merge the two sorted arrays in ascending or descending order, the elements from both the arrays are placed in the third array in the required order. So order is very important. We have to see the element from which array is to be placed in the third array. So the third array also remains sorted. The merging is completed when all the elements from both the arrays are placed in the third array. So now let us see how we can write a program to implement merging. So in this we assume that there are three arrays A, B and C, and A is of size M and then it is sorted in ascending order. B is of size N and it is sorted in descending order. Then we are copying the content of A and B to array C, which is of size P, and we want C to be in ascending order. So this is all what we have written. So let us come to main. In main we have declared three variables M1, N1, P1 which are containing the sizes of the three arrays. So this is the first array. See, you can see here this is in ascending order, and then this is the second array Y which is in descending order, you can see, and this is the array Z. This is the third array and of size P1. Now we are calling a merge function. In the merge function, we are passing all the three arrays and their sizes. You can see here, this is an array A, size M, B of size N, C of size P. Now it is very important to check whether it is possible to merge the content of array A and B in C or not. So if P is less than M plus N, if the size of array C is less than the sum of the sizes of array A and B, then you can see the merging is not possible and we will exit. Now, to store the contents in ascending order in the array C, we need to read array A from beginning, but as B is in descending order, so we will read B from the end. So you can see I have initialized I by 0 but J by n minus 1 because I will read the array B from bottom. I will read the array A from top but B from bottom, and K is equal to 0 in the beginning itself. So the loop is I less than M and J greater than equal to 0. Since I is 0, so it should go to each and every element of the array that M till M minus 1. That is why I have written I less than M. And J is N minus 1. So I am going backwards from bottom to top. So I have given the condition J greater than equal to 0. Now I will check if AI is less than Bj. If this element AI is smaller than Bj, then Ck will store the element AI and both K and I will be incremented. Otherwise, Ck will contain, the array C will contain the element of Bj and K will be incremented but J will be decremented. Now this process continues until one of the condition becomes false. Now if any one of the condition becomes false, it means one array has finished but the second array is still remaining. It may happen. So we will check whether, now we are using this loop I less than M. If I is less than M, it means the array A is still left, the elements of the array are still left. So we will copy the elements of this array in the array C in linear order. And if J is greater than 0, it means the elements of array B are left. So we'll copy them in array C in linear order. So after this, the contents are merged and we will get back when we will return to main. We can use the loop to display the array Z, which is same as C. So let us see the memory diagram of it so that it becomes more clear. So this is my array A, you can see here, which is in ascending order, and this is my array B, which has 5 elements in descending order. Now this is my array C, which is generated after the merge operation. So let us see how this loop works. Now while I less than M and J greater than equal to 0, in the beginning I is 0 and J is N minus 1, that is 4. So this condition is true. You can see I is 0 and J is 4. Both the conditions are true. AJ is 5. This is the element. And AI is 5 and BJ, you can see J is n minus 1, that is 4, j is 4. So this is my bj. Bj is 8. So ai less than bj is true. So ck will contain ai, which is 5. So you can see here c is containing 5 and k will be incremented and I will be incremented. Now in the next case, again I has been incremented, I is 1, j will remain 4 only, I less than m is true and j greater than equal to 0, that is also true. So the loop will work and ai is 48 now and bj is 8. It will remain 8 because it hasn't been incremented. Now is ai less than bj? It is false. So this time c will contain the content element of array b. So ck is equal to bj, which is 8, and now k will be incremented and then j will be decremented. Now there is no effect on I, so I will remain 1 and j has been decremented, so j has become 3. Now both the conditions are true. ai is 48 and bj you can see is 42. So again the condition is false. So again bj will be copied to ck, that is 42. You can see here 42 is copied to this and k will be incremented and j will be decremented. So I remains unchanged 1, j is 2. Both the conditions are true. Now ai is 48 and bj is 68. This time the condition is true. So the content of ai will be copied to ck, that is 48, and k will be incremented and now I will be incremented. So I will become 2, j is also 2, both the conditions are true, and 55, 68, so this condition is again true, and again the array content of array A will be copied to C and k and I will be incremented. So again I is 3 now, j is unchanged 2, both the conditions are true, and then A3 is 69 and Bj is 68. Now the condition is false, so this time Ck will contain the contents of Bj. So 68 will be, you can see, will be copied to Ck and K will be incremented and J will be decremented. So I remains unchanged 3, j is 1, both the conditions are true. So ai is 69 and bj is 75. You can see in the arrays the condition is true. So content of a will be copied to c, 69 you can see it is copied to c, and k will be incremented and I will be incremented. So you can see I is now 4 and j is 1 and I less than m is false. I less than m is false because I and m now they are equal. So I is not less than m and j greater than equal to 0 is true. But we have written and here, so both the conditions must be true for this loop to run. So this loop will break and it will terminate, and now the loop 3 will be executed. You can see here the array A has ended. So this loop will be executed now while j greater than equal to 0, and all the elements, remaining elements of B will be copied to C. So these two elements were left, 75 and 96 were left when this loop was terminated. So they will be copied, 75 will be copied first and then 96 will be copied. So you can see all the elements of array A and B are copied to array C in ascending order. So this is how the merging takes place. So this is all for this session. I hope you like this video, and if you really like it, please give thumbs up and subscribe to my YouTube channel. Thank you.